still 2, and then we discussed 3 in each one of them, macro and micro. And the last thing which we were doing was looking at these graphs, okay, and they are all part of what? Nothing. Okay, but they are all part of traffic flow theory. Okay, all these graphs and equations are all part of traffic flow theory. Okay, so the concept of traffic flow theory was given by Bruce Greenshields in my childhood, which was 1930s. Okay, and the first thing he came up with was the relationship between speed and density. Okay, so he said it's a straight line, you know the equation of the straight line. Okay, so he plotted this line and he said, okay, y equals to mx plus b, this is m, this is x, this is y, this is b, and this is how you make the equation. Okay, so he came up with this equation. Okay, I showed you last time how it is made, and I believe we covered these equations at your right. Okay, so this is the equation of the straight line, and this is the core equation of traffic flow. Okay, so you replace s from here, becomes v upon d. This is the equation between v and d now. Okay, and then you have d over here. Going back to this equation, now d will be replaced with v upon s. Okay, and then you have the equation between v and s. Okay, so the first equation is for a straight line, which is this one. Okay, the next equation, flow and density. Is it a straight line? Is it a straight line? No, right? So what type of shape is it? This one. Quadratic. Okay, so that equation is for this curve. Clear? Okay, and this one, the second one is for the other curve. Again, second degree, right? Clear? Now, on these curves, there is a point on the top side, okay, and we are calling it what? Capacity. When you reach this point, the slope becomes what? The slope. Don't look at my hand, like look at the curve. My hand is showing negative, but what is the slope here? 0, right? Okay. So the equation of this curve is this one. Okay. And I want the slope of the curve. So what do we do? From the equation of the curve, how do we get the slope? Yes. We will substitute inshallah in the exam. Yes. See, slope equation. Y equals what? Mx plus b. Okay, do it. This morning I was teaching the 209 students that you don't have to just look at the solution. You have to look at it is real, but it's practical. You can do it or not. Okay, so when you say things like this equation, that equation, substitute, interpolate, extrapolate, you have to think, can we do it? Okay, but eventually you have to do it. Right? Anyways, slope is a ratio, right? Slope is a ratio. Okay, so to make this equation into a ratio, I have to take the derivative. Okay, I have to take the derivative. So if I take the derivative, dv upon dt. I've already done it. I will do it on the board. Okay, dv upon dt. Is it a permanent marker? Okay. So what will be the derivative? 65 minus 2 times 0.5909 d, right? Okay. And when the curve reaches maximum, we said the slope becomes what? 0. Okay. So this whole thing becomes 0. Okay. Then this whole thing becomes 0. Then what is d? How much is d? 55. Okay. Is it any value of d? It is a, no, it's not the capacity, it is d at capacity. Okay. Because this d happens when slope is 0, right? And when the slope is 0, at capacity. Right? Clear? And we can do the same thing for this equation as well, the second one. It's also quadratic. Maximum point will again have slope 0. Okay, so you take the derivative dv by ds and you put it equal to 0, right? So this gives you s of how much? 32.5. Before I move forward, I'll go back. Now look at these values here. Okay, 65 is what? Free flow speed, right? This value. How much speed you got? 32.5. Do you see the relationship between them? Yes? What do you mean? Yes. Okay, so free flow speed is double of this one, right? And again, this one is speed when you reach capacity. We call it critical speed. Okay? So the full speed is double of the speed at capacity. Got it? Okay? Then you look at this one, jam density. This is 110. And your critical density is 55, which is half. Okay? So this is mathematical. Okay? Values can change, but the relationship is there. Okay? This is twice, this is half. Clear? Okay? Now, you see three equations here. Okay? This one, flow equals speed into density. Do you know speed? You know density? I can calculate flow, right? If I put these values over here and calculate flow, what do I call that? Very good, because everything was critical, right? Critical speed, critical density, so critical flow. Huh? Now, why we are calling them critical? We are calling them critical because of the flow. So flow is called what? To calculate them, we put the slope equal to 0, right? Slope is 0 at what? Slope as 0? Yes. Slope is 0 when you reach capacity. Okay? So if you put these values in the equation and calculate flow, that is your capacity. Clear? Sure. Okay, I don't know why I have this. Anyways. Okay, so what is the flow? What is the capacity over here? You put these values, multiply them. You multiply them. What did you get? Yes, 55 into 32. Yes. 17. You keep the 87.5. Okay. You keep these all 0.5, 0.3, 0.2, and then we will see how many vehicles you got. And we'll buy them. Okay. Everybody see this. Okay. Any questions? Any problems? Okay. So I believe someone from you asked me that will these equations be given. Okay, I'll show you another question. This one. Okay. You see the first equation was between speed and density, right? Okay. You look at this equation and you look at this one. Are they same? Are they same? No. Are they similar? Yes. Because the equation is for a straight line, so this is similar. Okay. So to get to here from here, I follow the same steps. One by one, I follow the same steps. So you need to keep this in mind. But if you are saying I will give you a fixed equation, like this equation is given just to get you started. Okay. But the rest of the thing is steps, not the equation itself. Okay. So you will not get this equation every time if you take the derivative. Okay. Because it depends upon road. All roads cannot have the same frequency. All roads cannot have the same density. All roads cannot have same capacity and critical density. That? Okay. Any questions? Okay. So what are they asking for in this question? First of all, you have to find out the free flow speed and jam density. Okay. We are still looking at the same straight line. Equation has changed, but the straight line is still the same. So I have an equation between speed and density. They are asking me for free flow speed. Okay. Free flow speed is this point. If I have this equation, how do you get to this point? To get to this point, what should I do with this equation? I don't know this one. How much is this right? I have the equation. What should I do here? To get at this point, when density is 0. Okay, so the equation you put density equals 0. That will give you free flow. What about jam density? What is speed equal to? Clear? Okay. So now tell me what is the jam density and what is the free flow speed? Okay. Fortunately, this equation doesn't have any constants on it. This remains as it is. Okay. So whatever equation is given to you, you can replace s with d upon d anyways. Okay. So like we did here, you will do the same steps. Same. With that equation. Got it? Clear? Can you do it? Yes. Can you guys do it? Nobody is asking. You are doing it now, huh? Can you do it now? Like in 2 minutes. Too much, right? 1 minute is enough. Huh? Using ChatGPT. ChatGPT will not work. Last exam I gave chat, not ChatGPT, something, the file, and asked it, give me the question and the formulation. Even from the file it gave the wrong formula. Yes. V equals 71.2 D minus. Why you have bracket? You already opened the bracket, right? That's why I have D here. You already opened the bracket. Okay. 71.2 divided by 122 D square, right?
Yes.
And for the other one? Again 71.2? S equals V equals. V and speed. Speed and flow. Flow equals what into speed? The speed should be on the right hand side. Yes, so 120, 20, 22. Only? No. When what equals 0? No, not speed. What was 0? Derivative. Something was 0. Something was 0. There is always something 0. There is always something 0. Either the value or your marks or. Okay? So, yeah, you take the derivative put equal to 0, you will get critical speed, critical density, like we need here, right? This is one method. Okay, so for each of these equations, you will take the derivative put equal to 0, you get the critical density, critical speed. Okay, but when we did this over here, we found another relationship, which was what? When we found these values, then we found that these values are connected to these two. 50%, right? So we already calculated these two values, right? If your speed was 71.2, jam density was 120. I can directly take the half. That would be critical speed and critical density. Okay? Clear? Clear? Okay. So if you take the half, then your critical speed equals to how much? Half of 71.2 is how much? 35.6. Okay, and half of 122 is 61. Any problem? Everything good? Okay, then you just multiply them to get the capacity. So how much is it? 217.6. Okay, so you have 0.5 vehicles from before, 0.6 now. 1.1 vehicles. Okay, just keep a record. So you can see in the last question it was 1,700 something. This question is 2,700. There's a lot of difference. Okay, so that's why I keep on saying that you cannot expect these equations to be same. Okay. Okay. So all these equations were for uninterrupted flow. Now what is the difference between interrupted and uninterrupted? It was in the first lecture. What is the difference between them? Yes. Okay. One has intersection, the other one doesn't have. This one has intersection. Okay. Now what happens if a car comes at the intersection? Huh? How? It will decrease. Decrease the speed of it. You don't have to stop. Right? And how are you guys alive? Why are you alive? You have to stop, right? Most of the time you stop. There will be something for you to stop, make you stop, right? So this is stopping. Now remember we looked at those graphs. Okay. So there was a jam batch where everything was stopped. No speed, no flow. Okay. But they are cars which were making you stop. The jam was because of the cars themselves. Okay. But on intersection, you are the only car, but the signal is red. Okay? I have a lady at my house who says white rice. Do you agree with that? me your registration. Okay, but the signal is red, so you stop. Okay, this stopping is not because the road is full. We need jam density. This is because something external is stopping us. Okay. These equations, the equations which we have just seen, all of that, all the graphs, do they have something for external stopping? So the speed will become 0 when the signal is red. Where does it say in the equation the speed will become 0 when the signal is red? There is no signal there, right? In the equation, there is no effect of the signal. Okay? So those equations and graphs cannot be applied to interrupted flow conditions. All those graphs and equations were for uninterrupted flow conditions. Right? And the main reason is the external factor. The traffic, even if it slows down, okay, even if it's just slowing down, you're coming to a roundabout, nobody is coming from the other side, so you will slow down, hopefully, and you will go. Okay, at least you will slow down. But that slowing down is also not for traffic. It's not like traffic increased on my side, so that's why I'm slowing down. No. You're slowing down because something is approaching. Alright? So these equations do not work there. But once you pass an intersection, usually passing from the intersection is in the form of groups. Some 10, 12, 15, 50 meters pass together, like one after the other. Okay, a good example is the signal. Okay, so you are, the signal becomes green and a bunch of vehicles pass together. Okay, those vehicles which enter the intersection in succession, they are called as platoons. So what is a platoon? Which enters a road segment in the form of a group. Okay, so there is no big gap between them. Okay, just moving on as a group. Now the intersection was the interruption, right? The intersection is the interruption. The next intersection is after 2 kilometers. In these 2 kilometers, there is no external interruption. Vehicles are moving as per the design of the road, as per the traffic condition, right? Which is the case of uninterrupted. So once you pass through the intersection, this group which pass together, this platoon which pass together, they are behaving in an uninterrupted manner until they reach the next one. There? Okay? So even between the intersection, these equations are applicable. Right? Okay? But there is a limit to it, and that limit we will discuss later. There is a limit after which this happens. Okay? But the point is, between one intersection and the next one, the vehicles are uninterrupted. So those equations and graphs can be applied. Okay. We have already talked about volume and capacity, right? We just calculated capacity, which is what? What is capacity? Maximum? And you are reading it? No, not reading it. You will never read it. Yes, maximum flow, maximum vehicles, okay, whatever. And we have volume as well. Volume is what? What is volume? You started with volume, right? The first question it was for volume. What is volume? Number of cars passing per unit time. Okay. The capacity which we calculated, what was the unit of time? Hour. Okay. And volume can be per hour. Volume can be per hour, right? Okay. So this is similar to it. Volume can be vehicles per hour. Capacity can also be vehicles per hour. But capacity is what? Max. Volume can be 0. Okay. Volume can be 2, 3, 10, 100, 200. Okay. When it reaches maximum, we call it capacity. Okay. And capacity can be or is most of the time in terms of rate of flow. So it is still per hour, but it is not maximum volume. It is maximum rate of flow. Okay, you know the difference between volume and rate of flow? Okay. It's Ramadan, I can trust you, right? You say yes, that means no.
Volume is
No, no, no. I trust you. It doesn't move. Okay. Then we have demand. Demand is the number of vehicles, a number of people that want to traverse the highway. Okay? So capacity is maximum, volume is anything which is there, and demand is which want to be. Okay? Okay? So the road has a capacity of 2,000 vehicles. It will remain 2,000, right? Capacity cannot change. This room has a capacity of 30 chairs, it will remain 30. Okay. But if I take these chairs outside, this chair outside, and whatever, 2 chairs outside, the actual number of chairs will be how much? 28 now, right? Okay. But is this the capacity? No, capacity is still 30. Somebody can bring the chair and put it. Capacity doesn't change. The volume can change. Okay. If somebody brings 40 chairs and they want to put it in this room, okay, possible? Okay. So, but they want to do it. So, what they want to do is what? Demand. Got it? And that demand could be, now I need 28 chairs, which is enough. Okay, so no problem. Then at other time I need 50 chairs, so now I have a problem, right? So demand can go even above capacity. Okay, but the volume cannot. Clear or not? Okay? So when demand exceeds capacity, in your traffic book they have done a very good thing. They were already doing it. You know, they have done it with the new edition as well. They are talking about these concepts as well. This happens and what would you do? This happens. You will see it in the other slides and the book if you see the book. I don't know when. So for example, demand exceeds capacity. We said it can happen, right? Somebody is outside and he wants to bring 50 more chairs inside. It's not possible, but he wants to do it. Okay, so the demand can be above capacity. Okay. When something like this happens, demand goes above capacity for the road, then what will start? A queue. Okay. Congestion, traffic jam. Right? So, what are the things which drivers can do or they do when they need this type of situation? Okay, not all of them, but these are the options which they can do to avoid the situation. They can go from other routes, right? Can be the Einstein and okay, let me take this street. Nobody will think about it. The road is very busy. Oh, this is street. Let me go here. This is like this is invisible. Only I can see, right? Nobody else will see. Let me go. Okay, so they can go from other routes. Okay, they can travel to other time. Okay, tell the doctor that on this day I have only one class. Why should I come? Right? Let me attend the other section. That is right. Okay. Second example. Travel to a different destination. UOB is very far. I don't live in Sakhi or town. Let me take admission somewhere else. Everybody is thinking about it, right? Wasting our life. So, but this generally happens for non-essential trips. The third option happens for non-essential trips. Shopping, playing, cinema, bank, okay, sorry, restaurants, okay, non-essential trips. No question about it. Okay? When you will go in the field, you will want to come out. Okay? If your boss says stay home and work, you say no. Okay? I'll come out. You know why? Why? No?
Maybe the environment and no one wants to go to work.
Maybe the environment at home is not suitable to work. Yes. Yes. But that happens after marriage, not before. The thing is that at home you are 24 hours, right? So the boss says your office is, your home is your office. So that means your office is 24 hours. Okay, this is what is happening now. Even without this. Anyways, the point is, all these people who are not doing this are part of the demand. The actual demand is people who are stuck on the road, people who took the other route, people who went to other destination, took other time, or stayed home. Okay? So the total demand is those people who can count on the road plus all these. And this creates a problem at the time of planning. Everybody is planning for who? People who are in the traffic jam. These people are invisible. You don't see them. You don't know about them. You don't know how many people have cancelled their trip because of this traffic jam. How many people are just driving from other highways? How many people are not going to this mall because there is a traffic jam there? Okay? So this is what happens. We have seen them, maybe now you are old enough. You may have seen on some highways, they opened them a few years ago because, new highways or new bridges and so on, because there was too much traffic. And after a couple of years, same thing happens. Okay? So people think that now this is a good highway, it's a better route, a better time. Let me go there. Okay? Okay. Now you will see what to do mathematically when the demand goes over capacity. Okay, so this is like you have a road here. Okay, on this road they observe demand somehow, and they plotted it on the y-axis. Okay, so this line which you see is the demand on the road. Okay, this one is the demand on the road. Okay, and this one, the straight line, is the capacity. Because its capacity is a straight line. We already said. You see, at this point of time, the demand is below capacity. No problem. At this point of time, demand goes above capacity. Problem. And then at this point, it goes below capacity again. Okay. Now, what we are looking at here is a simplified version of the problem. The demand does not go up and down like this. Okay, it goes gradually. But just for the sake of understanding, we will look at this example. Okay, the difficult one, we will keep it for the example. So, in this situation, there are three things important for us. How long will be the queue because of this situation? How much time you need to clear the queue? And what will be the delay because of this situation? The total delay as well as aggregate. Okay, so we are trying to calculate three things: the queue, the clearance time, and the delay. Okay, we'll start first with the queue. Now, at this point, the capacity of the road is 75 per minute. This is per minute. So 75 per minute. Okay. The demand is 120. Okay. What is the difference between them? How much? 45, right? 120 minus 75. 45. Clear? Okay. This is 45 per minute. So every minute, 45 meters. Difference. Okay. And this continues for how long? It starts at 30 and finishes at 90. 1 hour. Okay, 1 hour. So in 1 hour, every minute 45 meters. Clear? Okay. So every minute 45 meters, meaning in 60 minutes you will have 2,700. Capacity, demand, difference, right? Per minute. For how long? 60 minutes. There. Okay. So the total Q will be this much. So for 1 hour, every minute 45 liters are coming to the Q. So after 1 hour, we will have total of 2,700 liters there. Clear now? Okay. Now what happens here at this point? Demand drops, right? Drops. Drops to what? 65. 65. The capacity is still 75. Okay. So 65 liters are coming and 75 can go. Okay. So how many will go actually? 65 or 75? 65. And these 2,700 liters, we fill them out. 10 of them we can go wrong.
Yes.
Because think of it like an extra space. The space on the highway is total for 75 meters. I have 2,700 meters waiting. Okay. So from this minute onwards, I have an extra space of 10 meters. Demand is 65, capacity is 75. So I have an extra vehicle of 10, extra space of 10 meters. This 10 is also per minute. So 10 vehicles per minute. An extra space of 10 vehicles per minute. Total vehicles I have is 2,700. From 2,700, 10 will go every minute. So in how many minutes all of them will go? Clear now? Any questions? Any problems? Okay. So we have three things to calculate. One was the length of the tube. The other one was the clearance time. And the third thing is the delay. Okay. Now we will look at the delay. Okay, for the delay, we have to make some, do some calculations. Just quickly go through it. Okay, I will plot, or I need one more. Okay, I have time. I have vehicles coming. I will call them vehicles arrived. And I have vehicles leaving. I'll call them vehicle departed. Okay, I'm now talking about total, not per minute, total. Okay, per minute I already know from the first graph. It's already given. Total. When time was 0, everything was 0. Per minute, right? So minutes are 0, nothing is there, right? Next 30 minutes, the rate of coming is 50. Okay. So when time is 30, vehicles are coming 50 per minute. Okay. And since it is below capacity, all of them can leave, right? Okay. So this is same rate for coming, same for leaving, right? Below capacity, there is no problem. Okay. Next one, for the next 1 hour, like from 30 to 90, right? 30 to 90. For the next 1 hour, they were coming at 120 per minute, right? 120 per minute. Okay. And I am calculating total from 0. So I will add this one. Okay. 1,500. I will add it plus 120 per minute for 60 minutes, right? 60 minutes. Which gives me how much? 8,700. Okay. Can somebody give me this number?
6,000.
Yes.
6,000.
How 6,000?
1,500.
You added, okay, 1,500 and they are leaving at 75 per minute, right? Okay, so 1,500 plus 75 into 60. Clear? Okay. But you know after 1 hour how many meters are in the queue? 2,700. Total is 8,700. From 8,700 these are in the queue. So the remaining left. Clear or not? Okay. So even if I don't do this, I know 8,700 minus 2,700 of the queue. Okay, easier? Because you already calculated the queue. Otherwise, you can do the same thing. 1,500 plus 75 into 6. Okay? Any questions? Okay. Next is when they will clear the queue. The next point is when they will clear the queue. They need 270 minutes to clear the queue, right? After 90. 90 plus 270. How much? 360. Okay. In 360, we can do the same thing again. Now I will add this 8,700. What was the rate at which they were coming? 65 per minute, right? So 65 into 270. I got how much? 250. And how much will be the number here? Without calculation. Without calculation. How much? All of them left, right? Q is cleared. So that means what? Same number, right? If you want, you can recalculate and check. Okay. So now you will add 6,000 plus again 75 into 270. Okay. But it should be the same because there is no Q now. Until there is Q, the numbers are different. If there is no Q, the numbers are not different. Okay. Just for your sake, I will write this over here. So the old number is 6,000 and they are leaving at 75 per minute for 270 minutes. I know this is big things. More. Okay. There, up to here. Any problem? So you have got time and then you have got two values of flow at each time, right? Two values of flow at each time. So this is what we have plotted in this graph. Okay, so I use this table and plotted this graph. Okay, time here, first column and the last two columns, they are plotted. Okay. This column, you see a straight line after 30. A straight line after 30. Okay. Which is the departure column. Because after 30, they are leaving at 75 per minute. All of them, right? 95 per minute. Okay. This one is for the vehicles arriving. So you see up to 30, one slope. Up to 90, another slope. And then another slope. Okay. Because the arrival rate is changing, right? The rate at which they are arriving is changing. It was 55 here, 120 here, and 65 here, right? So that's why you see the changes. Okay. Now you are trying to calculate delay, right? Delay. Delay is the difference of area between the two lines. Okay. The difference of area between the two lines. Okay. Clear? We divide these two lines into two triangles. The area between them, we divide them into two right angle triangles. Okay, this one and this big one. Okay, so there are two right angle triangles. What is the area of right angle triangle? Half Height and base. Okay. So half. What is the base? From 30 to 90, right? Okay. What is the height? Not the full height. I need the difference, right?
Yes.
So I will not take the full height. I will take the difference of these two. So how much is the difference of these two? You already calculated. Okay. Got it? Okay. Clear or not? So first triangle, second triangle. The difference will still remain the same, right? These two lines. Difference is same. And the other point is 0. Okay, the difference is same. The base is from 90 to 360. Okay, which is, so I plotted the arrival line, departure line. I need the difference of areas between them. Okay, I divided into two right angle triangles. Right angle triangle is half base into height. What is my base? The difference of time. What is my height? The difference between the two lines. Clear? Okay. So you get these two areas, you add them together, you get total delay. This is my total delay. This is in minutes because the graph is in minutes, right? You want it in hours, you add the 60. This is in hours. This is total. Total. Okay. Now if you want average, the average is total upon number of vehicles, right? Total number of vehicles. Total I already have, this one or this one, whatever you like. I need number of vehicles who are in the queue. Number of vehicles who are in the queue. The delay was faced by who? Who was in the queue, right? So, number of vehicles in the queue. When the queue started? 10:30, right? 10:30 queue started. When did it end? Time 360. How many vehicles came in between them? At time 30? At time 360? What? Between them, right? Difference. Okay, queue started here, ended here. All these vehicles were in the queue. Okay, so at time 30, the queue was, the number of vehicles is this much. At time 360, number of vehicles is this much. You take the difference, you know how many came between them, right? Clear or not? Clear or not? No? I need number of vehicles which came between 30 and 360. 30 queue started, 360 queue ended. Okay? So number of vehicles total at 30, 1,500. Number of vehicles 360 from start to 360. Yes, 26,000 something. I want between them, right? I take the difference. Okay? So these are the number of vehicles we have, which is equal to this much. There's another method written here, you can go through. Okay? But this is the easier one. You already have the number, so take the difference. Okay? So total delay, this much. Number of vehicles, this much. You take the ratio, you get average delay. Okay? Clear or not? Any questions? Okay. Two important points. The first point is the demand increased for 1 hour. The queue was from time 30 to 360, which is how many hours? How many hours? 30 minus 360 is 330 minutes. 330 minutes means how many hours? 5.5. So a jump in demand for 1 hour can cause a delay of more than 5. This is what you see in the morning. Okay? And the delay, if you take the average, it's 18 minutes per week. So that was supposed to, on average obviously, on average. I was supposed to reach some place at 5, now reach at 5:80. What? On average. Some people will be even more than that. Some people will be less. Clear now?